Hey everyone, my name is Mark Parisi. Welcome to my talk. I would have been giving this excuse me, conversation during ApacheCon 2022, but unfortunately I tested positive for COVID, so couldn't travel to New Orleans. My family and I are sick. I'm getting better and on the mend, and I really wanted to give this conversation or this talk rather. So I'm a PMC member on Apache Cumulo and Apache NiFi. As you can see on the screen here, you can see about the time I became a manager on the screen. You can see my contributions from the last 3 years. I'm currently a group engineering manager at Microsoft, which effectively means I manage a set of teams and a set of services. None of these relate to the work you'll see here, and I'm not here representing Microsoft. In fact, I'm here as an independent researcher and someone who's interested in consumer security as it relates to IoT. So today, I wanted to talk through a little bit about what IoT is, and really this is just a level set on what IoT means for end consumer devices. And we'll go through an interesting scenario. As I wrote in the abstract, I really did have 98 IP addresses associated with my network. Naturally, it was a little bit extreme, but I really wanted to talk through this as a conversation point to really hone in and focus on what it means for consumer devices and the security therein. In terms of IoT, naturally, I think we fully understand the fact that we have many devices that are interconnected. We have many devices that are providing data, sensors, phones. Some of them would want to provide data. Connected cars, smart devices, industrial IoT, and enterprise IoT all provide data in some form or fashion and generally send it to some other external service, whether that's on the internet, whether that's in the cloud, etc. The typical assumption is that IoT devices care more, or industrial IoT devices rather, care more about security. And the important part about this is that it's generally true that industrial and enterprise applications have more of a focus on security, but I think we could take a better approach and really all of the devices that we use on a daily basis have a security threat, whether that's our vehicles, whether that's the devices in our home, whether it's the devices we play with, whether it's the devices we learn with. So what you have in front of you is my network, my home network. And you can see I have a relatively complicated setup, and some of this is just a function of me being someone who loves technology, who loves to learn, who loves to do things. I have a smart mirror off camera. I have some robotics devices that are driven by Rasperry Pis and Arduinos. What you see here is, the first and foremost, this is not a paid promotion for Ubiquiti. I do love their products, and I've leveraged them for networking, but I simply use them because they provide a great deal of visibility into my network. Now you can see I have several APs. I have a repeater, which is effectively just the ability to sort of provide a homogenized network across, or a homogeneous network across the environment with it, which is inside and outside of my home. I have several switches, PoE switches, 24 port and several 8 port that go to my attic, and I'm here in the basement at the moment. And the devices provide coverage in and outside of my home. As I said wrote in the abstract, I did have 98 IPs allocated, and many of them were done by way of Proxmox driven VMs. Proxmox is the hypervisor. It's a KVM based solution on 2 Dell servers with 24 VMs providing a variety of functions throughout their home, from automation to monitoring, security monitoring, things like pfSense. Many phones and tablets, desktop PCs, which also ran VMs. And then come the IoT devices and the devices, the things that provided data or capabilities on my network. My Raspberry Pis took around 30 of those IP addresses. These are environmental sensors. For the life of me, I currently don't understand why I had that many devices in my home. I had automation for things like opening and closing garage door or opening and closing doors. I had a garage door opener, smart mirror, as I mentioned, network attached storage, small home, small office, home office devices for printers, scanners, video game consoles, smart home watches, the doorbells, the smart home hubs. I have all of that. I also had industrial IoT devices that were sensors and industrial fanless computers that focused on providing an IoT experience within the field, or in my case, my backyard. And these were devices that were generally Windows based, and of course, last but not least, we have the UDM Pro and all the ubiquity gear that provide my network capabilities. What you see here is the UDM Pro's interface that shows my network. You can see I have actually some devices here that I didn't call out in the prior slide. Many of these are home entertainment devices like Roku or the Harmony Hub, which is the remote controls for Logitech. And then you see the PlayStation, Nintendo Switch, the cameras, and you can see the amount of data that you see on the screen for the under 24-hour usage is quite large. And these aren't all the devices. This is just one segment, out of the scroll further to show the other devices. And I think this was actually taken a month after I started reducing the number of VMs on my environment. So you can see all the devices, all the virtual machines, all the computers, and all the things that are taking IP addresses or allocated IP addresses. And in the beginning, I thought, well, I have a really good handle of this security thing. I've worked in computer security previously. I had a separate VLAN, one for the main network, a trusted IoT network for those devices, which I thought should connect to the internet. And these were things like Google Home or the Nest doorbell. And then I had an untrusted network, which was completely separated from the internet, disconnected, as I call protected. I have this mantra: isolate, separate, and protect. And what that meant was I had an isolated VLAN. Some were separated from the network or from other parts of the network, and some were protected from connecting to the internet at all. And I would effectively limit their connectivity. And then I also started exploring through research efforts just an understanding of what it meant for devices to connect to their points of origin. A good example is my NAS, my network attached storage, that would, in cases where I would block from the country of origin, it wouldn't work, and it required that it phone home. Another one, is we'll get into in a little bit, is my doorbell, where it would connect to Taiwan, which is where it was, again, its country of origin. In most cases, I don't feel that this was a really valuable tool. The switches provided that capability, and I found that in many cases it wasn't as valuable as just disconnecting the device from the internet entirely. So this is one of my cameras. What I'd like to call it here is, I think I fell prey to the appeal to closure, which is written here. And for me, it was, one half of that is that for me, it was important as I went through my network and I tried to keep things up to date, that if there was not an update to be had, then I was secure. The inverse of that is also true, which means that if there weren't an update to be had, then I felt secure. And if there was not an update to be had, I felt as though I'm good. And so if an update's available, I would just go out to get it, apply it, and I felt like I had closure, and I couldn't allow the point to remain unsettled. And no matter how, to me, that's incredibly, it's questionable in my mind, which is, it's a logical fallacy that if there's not an update, then I'm good, because ultimately the CVE here points to the cameras, many on my network, which had a known vulnerability as a result of the CVE, and it was about a month after this, the last update in 2020, that this camera manufacturer produced the firmware. So for me, it's unclear if, in this case, is it true that the camera no longer has vulnerabilities as a result of the fact that no more firmwares are being produced? Is it true that this vulnerability, since it coincided a month before the CVE notification, that they worked with the identifiers of the 0-day to resolve it before the CVE was published? I don't know. I reached out to the manufacturer and they suggested more. They ignored the fact that any comment about the CVE specifically, and just noted rather that I should, if I have concerns, I should update to a more recent camera. And of course, as I mentioned, I have around 15 cameras on my network. That doing that would incur a relatively high cost at any given point. So what happened? Initially, I was able to keep my devices up to date, and I think over time I accrued more and more devices. As I mentioned, I was a PMC member on Apache NiFi, Minify, C++, so I worked a lot with edge device manufacturers and IoT, people in the community. Over time, my life became much more complex, and you can see, naturally, it took a few years to have these 3 kids, but life sort of gets in the way. Life gets in the way of it's typically much more important than making sure that all of my devices are up to date. My son's really unhappy that either we're taking the photo or my network's in such a vulnerable state. But it's very easy, especially with end consumers whose singular role is not administrator of their network, to keep everything up to date. So then where is that onus? Is that on the development manufacturers? Is it on the people? I would argue that it's naturally a shared responsibility. But even though I have an extreme case, the more devices we have and connected, the more difficult it is to keep them up to date and keep our network secure. So one of the big issues I ran into is that not all of my devices were connected all the time or powered on. And more so, many of these devices were in a power safe mode or power save mode rather. So example is my PlayStation consoles. Once I started having kids and more kids, I rarely ever played them, so I rarely turned them on, and they didn't auto update, but they did, through monitoring of my network over time. I did notice that these devices that were in power save network on my network, some of them were coming online for a very short period of time, or using low power to transmit across the network. And I won't call out specific devices in this conference talk, but suffice to say, devices that are in power save mode still have the ability to come online and do some operation. And the next set of issues and concerns are that not all devices are auto updated, and nor do we want them to be all the time. There are many enterprise applications of Windows, Microsoft Windows, where, and I should highlight, I'm not here on the behest of Microsoft, so when I call out Microsoft, it's just a factor of being in these environments and working in computer security for many years. There are enterprises within industry that don't update immediately. They do so, make sure that everything's good with the update, because there's a fear of the unknown. And I also have noticed the same in myself, when specifically regarding my Ubiquiti gear, I'm very hesitant to update because I've been, I'll use the air quotes, been burned, where I've had an update that caused me to have to reset and rebuild my network effectively. Much of this is not very complicated, but given that I have a very small amount of time to do things outside of work, it's unlikely I want to spend an hour or two re-adopting all the devices in my switch so that everything works together. And naturally, for many of these devices, there's also sort of another aspect where many of these devices are not connected to the internet, and we'll get into that in a minute. But I want to sort of highlight one story where I had a device where I noted initially this garage door opener. I had no need for a garage door opener being connected to Wi-Fi, but I tried to set it up. And when I did so over the course of the few years that we had it, we never had issues. And then suddenly, shortly after connecting it to Wi-Fi, I noticed every few weeks or bi-weekly for about 10 minutes there would be an issue. And this device was in the untrusted network, so it was disconnected from the internet. And initially I thought, oh, this is interesting. So I put it back on the internet, and I noticed that the issue wasn't there. So what I did, I also then sort of did, I put this in a VLAN where it was allowed to go to the internet and the trusted IoT network, and I captured traffic, and I noticed what looked like a heartbeat with a serial number, date, and a few other things. And I didn't fully understand it. It was more or less just, it was easy to notice because it was clear text, and at the time, this is a somewhat older model of a garage door opener. What I noticed is that during that hot loop, it would stop, it would retry every minute over the course of the 10 minutes if it couldn't connect to the internet. And then I tried, again, it was allowed to connect to the internet and everything worked, and I didn't have any issues. And I noticed the heartbeat went through, and then I decided to block the country of origin, which was very easy in my switch, and I noticed started having issues. So it was very clearly going to an IP address in its country of origin, and for perhaps support purposes, I don't know entirely of all the reasons, and it again started having issues. And what I surmised was that when the Wi-Fi was off, it wouldn't attempt, but while it was on, it would start having issues, which is really an interesting call out, because it kind of highlights the complexity of triaging an issue like this, which, you know, for someone like myself, I was able to do a packet capture, I was able to toggle internet connectivity, I was able to toggle connectivity to the country of origin. And again, I don't think that blocking in countries is a valuable part of this. I think this was more about validating and looking at devices across my network. I found that many devices did connect home or to a device in their country of origin, which is an interesting point of research. What I found that it was even, again, showed the issue when I blocked to the public internet. So I'm very cognizant of this, because for many of these IoT devices, I think a safer pathway for most devices, whether it's industrial, enterprise, or end consumer devices, it's safer to block them from the internet, but in many cases they don't work well. A good example would be Google Home or Google Nest. My Google Home, for example, which has a screen and it shows you could perform Google searches and ask it questions. Naturally, that has to be connected to the internet to be functional. But a device like a garage door opener, I wouldn't consider or even imagine that it being disconnected from the internet would cause problems. Now, part of the research for disconnecting from the country of origin was seeing what would happen if I allowed internet connectivity and allowed it to prevented it from connecting to the country of origin. And I noticed during this time that the garage door wouldn't go up or down either, because it required that connectivity. So because it required connections through two other countries, this is interesting, because depending on devices that are, sort of multinational, moved throughout the world, depending on countries where they may or may not have rules for connectivity to certain places for certain protocols or certain types of data, it's interesting, because the question then arises, if our devices must be connected to be operational. A good example of that would be garage door opener. I wouldn't expect that it would be fully unusable if it were connected to Wi-Fi and unable to connect to either the internet or the country of origin. Is that the right mode of operation for the device? So I think that's an area I wanted to further explore another venture, which is really how these devices work. Another good example of this was, as I mentioned, my network attached storage earlier. It would work. It would have some issues if it were connected to the internet, but not allowed to connect to the country of origin. And I noticed that certain features and functionality would and would not work in these cases. And I think that's another example where, depending on firewall rules or connectivity rules, it's hard for the end user to be able to triage what should and should not work. And here's another great example where this is my Pi-hole DNS server, which provides the ability to filter DNS entries and block on ads. And the first thing you'll notice, this screenshot was taken about 2 weeks ago. The date is October 3rd. And 2 weeks ago, the date was May 19th on the device. Now, I noticed many IoT devices have varying quality for their clocks and for the mechanisms that allow them to keep track of time, and there could be skew over time. This case seems a little bit extreme, so I don't know. I know I have set the device's date previously, but for whatever reason, it drifts quite a bit. The second thing you'll notice is that the network is unreachable because this device is in the untrusted IoT network. I don't allow it to update, or rather connect to the internet, and as a result, I don't allow updates to proceed. So even if I did connect this to the internet, it wouldn't update because the date skew is wrong. So the metadata that's pulled down from the apt-get update command will show incorrect different dates, and therefore the validation to perform updates wouldn't proceed. So this is sort of a secondary effect of isolating my devices from the public internet, is that they can't be updated. So this began me to think, after looking at devices on my network phoning home, my garage door opener having issues, my devices not being updated, what kind of vulnerabilities do I have? And I didn't purchase a vulnerability scanner. I used some that had the ability to do them in chunks, and I didn't scan my entire network, but I scanned a decent portion, and this showed a large number of vulnerabilities. And mind you, this is me allowing for auto updates. This is me having a minimized set of software packages deployed. I typically try to keep it to the bare minimum on many of my VMs. Naturally, I think in doing this evaluation, this scan, I identified most of my critical vulnerabilities were outdated software packages. But it's also interesting because every camera is vulnerable, and I don't have the details with me at this time, but in many cases this was the result of firmware updates and the scanners showing that there's a probability of exploit because of a configuration that opened things up. And it turns out that the manufacturer said or had written in the update for the firmware that you should save your configuration and then reapply it. But I noticed that most of the settings worked, Wi-Fi still connected, etc. So I made the gross assumption that as a result of that, they were perhaps wrong, or there were only certain cases where you had to do a full reset. But it turns out that it was just not obvious to me that those updates were wiping many of the settings. So for me, this is, again, another interesting area of further research that I think is warranted, which is even if a consumer or some administrator doesn't update, what are the ramifications of that update? Many firmware updates do clear out settings and configuration settings, but it's not always clear when and where. And I don't think that's always communicated either. But then there's just the general challenges of IoT. And this isn't new. This is every IoT conference I've been to, there's always a conversation about security. And I think the highlighted, the asterisk there of the strategic principles for securing IoT is from a DHS publication, I believe in 2016. But that document and many other conversations I've heard really focus on enterprise and IoT scenarios, which is again industrial IoT. And yes, there are many challenges for energy from electricity distribution. You have many places of data distribution and data that's all throughout the infrastructure, and therefore you have many challenges. And many of those may or may not be connected to the internet, but end consumer devices are almost always connected to the internet. It is almost never the case that an end consumer switch or router isolates devices from the internet. But there's also the lack of visibility into the data egress and telemetry that many of these devices pull. As I highlighted, some of my game systems, not the PlayStation specifically, but some of them phone home, and many of my other devices phone home. For my Windows VMs, there's the ability, there's some scripts that lock down telemetry, and Pi-hole, for example, also helps in that regard, but it's not clear to the end consumer. And for many of these IoT devices that I have deployed, I cannot tell you what data they're sending without doing a packet capture. As I highlighted, I have HVAC from the manufacturer. The device came with the ability to connect to the internet, and there's a useful app to control and monitor the temperature, much like my garage door opener. I don't know if there's what value I'm getting out of it, because I typically don't control the temperature from outside of the home. However, it is useful. But then there's another side of that where I don't fully understand or know what the implications are of these devices. There's an evaluation to be made of the risk benefit, but there's also an evaluation that the manufacturers make on continuous improvements, and they have to, over time, it's very difficult for end consumers or manufacturers to really understand the ROI with respect to keeping devices up to date. At some point, it makes more sense for the devices to no longer be kept up to date. And it makes more sense for end consumers to update the devices and replace them. My camera manufacturer, again, suggested that I do that for my cameras, but that's super costly, and we don't know, frankly, we don't know if that's going to come with a reduced or improved vulnerability management, because it's very difficult for end consumers to even understand the threat footprint of their network with these devices. So as part of being a developer for Apache NiFi, Minify, C++, I've had my hands in creating a vulnerability. This one specifically was published in 2021, and it was around updating an agent through the command and control protocols. And this was effectively giving you the ability to patch binaries or patch the agent on the device, such that it allowed us to apply updates if needed. But this came at, unfortunately, the result of this was that there was a known or vulnerability and a potential exploit path. NiFi is review then commit, which meant that I had multiple people review this. I also had some security folks review it. And at this point, nobody identified the bug. But in this case, I'm not victim shaming. I'm not saying that the people of NiFi or Minify are to blame. It was, in the end, my fault. It was my mistake in the code. But this sort of highlights another issue where anything, even the most intrinsic path to provide updates to make sure that devices are secure, can be potentially exploited. And it's very difficult for us, even as, and I'm not going to say I'm the best engineer, and maybe that is the reason why I wrote the CVE or wrote the code that resulted in the CVE, but even the most experienced people do make mistakes and do write bugs. So dovetailing into the solution, for me, this is an extreme example. And I brought it down to around 40 devices with as much automated tooling to shell scripts and bash scripts to check that things are up to date and provide me updates. But for me, it's the bigger aspect of this is making sure that we evaluate the risk and the benefit of the devices. For the garage door opener, the risk outweighed the benefit. For my cameras, that's perhaps a different calculation. The calculus is different on all of our devices. For many of the smart home devices, I think that work if they're disconnected from the internet. Then we could perhaps suggest that if we've isolated into a separate VLAN and we've protected the rest of the network from those devices, then we've done what we can. Naturally, the argument is if someone's in your network, then perhaps they've already gotten into you. However, I would argue in the previous slide with the Minify C++ exploit, if that were a device that was disconnected from the internet most of the time to protect itself or protect the network, but then it went to another source to perform an update, and it were somehow exploited, then suddenly you've given an attacker a path into the network. And then at that point, it's very difficult to calculate the total holistic security and depth risk of the entire architecture of your network. For me, it's more about mitigating the risk, though. To me, it's very difficult to codify the risk of IoT devices on an end consumer network. For devices that exist within an enterprise or an industrial application, those administrators, those engineers have a vested interest. They're being paid to keep devices up to date. And they may even have the wherewithal and the resources to purchase tools that allow them to monitor continuously and evaluate their network for vulnerabilities. And I would be remiss if I didn't mention that some systems, some software companies now produce agents that allow organizations to better manage and monitor the risk on those devices. But these all come at a cost. For end consumers, it's often not a tractable solution. The cost as far outweighs the risk mitigation. For me, on my personal network, it was mostly about risk exposure and making sure that the benefit outweighed the risk. But there was also the very real aspect, as I mentioned earlier, of separate, isolate, protect, which separating VLANs, isolating from the public internet, and then protecting the devices as needed. But again, this is very difficult for most end consumers, and also very difficult for devices in the public. A good point to highlight would be connected cars. So one of my vehicles was left stranded, or at least no longer had connectivity as a result of 3G expiration, but yet the device still has a radio. It still has capabilities that attempt to phone home. And me as someone who's I would argue somewhat paranoid, I don't know if this is an exploit path. I don't know if there is risk in this, and frankly, I also don't know how to protect it in this case. So it's very unclear. For me, in this specific case, that vehicle, I don't allow it to connect to Wi-Fi in my home or when it gets to the home, because it doesn't have a Wi-Fi radio, partially because I don't know what I don't know. From an Apache Software Foundation perspective, I think there are three major callouts that I'd like to make as part of this conversation. First and foremost, your code has legs, especially for these IoT projects. Philip 2 they make a smart home hub with lights, and those devices on my network, one of them actually now, one of the newer ones, has Bluetooth connectivity. And if you look at the Philips Hue app, you'll see mentions of open source software and the fact that they use open source software in their devices. Many of your code could be running on these devices, and for me, that scares me a little bit, because it means that all of these devices have code that exists in a GitHub repo or some other kind of repo, and do I know that they're keeping the code up to date? One might argue that having open source software is a boon in this case, because it does allow the manufacturer to get out of the business of writing a lot of custom code, and I do agree with that sentiment. But I know from my experience in Minify, there's a complexity with keeping dependencies up to date. So the threat footprint is not just the code that we write, it's the ecosystem that's running on that device. And knowing the complexity of doing this means that the complexity of keeping all of these devices in people's homes is also very difficult to keep up to date and to manage the vulnerabilities. And I think the argument typically made, these lights with the Bluetooth now, and with all the protocols that they run, I believe they run Zigbee if memory serves correctly, all of these devices running in my home, I've called out to people the fact that this is a potential security concern, and then they ask the question that my wife usually asks is, how much does it cost? And then, what is the risk? It's easier to quantify the cost than it is the risk. And then that allows us to fall prey to the sunk cost fallacy, which is that we've spent the money on these devices, why not just keep them? And it's harder to quantify the risk of the current state of the architecture, because I don't know what risk I incur by running these devices. The final call out, I think, I've heard of this concept of secure by design within software projects, and I'd really love to sort of hone in on this. I wish more projects would, in their README, the one thing that I tried doing before this conversation was searching the word security in several open source IoT related projects specifically, and if typically I would only find one or two words, but very little about the security risks of running the software in any type of IoT scenario. And I would like to see more of a conversation around being upfront about the risks that we incur on these devices, the risks that manufacturers incur, and that end consumers incur, whether that's industrial enterprise applications or consumer applications. For me, in the projects that I've worked in, as I mentioned, Apache NiFi, Minify, C++, in those variants, we defined a command and control interface, and I think it's important to note that anytime you provide such capability, you also provide a pathway as a vector for any type of attack, and you provide the ability for an attacker to do command and control on the agents. And that's just a great example of where having a conversation about any type of risk, and we don't need to get into theoreticals in READMEs, but having a conversation more in depth about security within GitHub and software projects, I think would be more valuable, because it's rare. It's usually prescient that we talk about security, and it's important. But in most GitHub profiles or project profiles and the READMEs, I see a conversation about what we're getting, what gaps the software project fulfills, but never do I hear or read anything about the risks that you could incur by leveraging this project in the wild, in IoT. And I think that's more warranted now, more than ever, with these devices. Naturally, I would open the floor to questions, but I'm afraid I can't at this time, given that I wasn't able to attend the conference. I'm incredibly apologetic to everyone that did make it to the conference, and hope that I have a chance to have this conversation in person again soon. Thank you.